Okay, so today is lesson 4, modeling with a quadratic, and our content objective is to use the key features of a quadratic to write its equation. Our language objective is to write equations from modeled stories with quadratics, so basically taking word problems and putting them into quadratic equations. So just quick refresher, we have our 3 forms of a quadratic. We have standard form, which is ax squared plus bx plus c, or y equals, sorry, I forgot the y equals, ax squared plus bx plus c. We have vertex form, which is y equals ax minus h squared plus k, and we have factored form, which is y equals a times x minus p times x minus q. So those are the 3 forms of a quadratic. When we are using or modeling using quadratics, we are going to figure out, based on our word problems, which one of these forms is going to be most helpful to start with. So to do that, we have to identify the key features. So just as a sort of like overview or broad conceptual understanding of what we're trying to do in each of these problems, we're trying to first identify the key features from the problem, or key features from the story. And then we're going to choose the most helpful quadratic form based on that. So we have a few different examples I want to go through. I'm going to start with one that's kind of familiar with us. So our first example, I want us to, or we're going to say Jason launched a model rocket from the ground. It hits the ground 7 seconds later. And reached a height of 2 feet after 1 second. Okay, so in this problem, we are going to first identify the key features from the story. So he launched a model rocket from the ground. So we know the initial height, or at time 0, so we're identifying key features. And our key features that we're looking for are those that are going to help us figure out which form. So do we know the vertex? Do we know the factors or the x-intercepts? Those are the first things we're looking for. If we don't have that information, we're figuring out how either we can determine that information or how we can use the given information to solve out in standard form. So in this case, we don't know the vertex because even though it says it reaches a height or reached a height of 2 feet after 1 second, we don't know that that's the maximum height that it reached since it was not explicitly stated. So we're going to assume that we do not know the vertex. So now we want to figure out if we know the x-intercepts. So vertex is unknown. So then we have to figure out x-intercepts. Well, we know initially, so at time 0, that is one of our, that it's on the ground. So we know 0, 0. So at time 0, so time and height, that's one of our x-intercepts. So one of our x-intercepts would be 0, 0. And since we know it hits the ground 7 seconds later, we know another one would be 7, 0. So again, it's back on the ground after 7 seconds. So we know both of our x-intercepts. Since we know both our x-intercepts, we know we're going to use factored form. So we're going to choose quadratic form. So we're going to choose factored form. So if I plug in my known information, I know y equals a times x minus 0 times x minus 7. So if I simplify that equation, I get y equals a, x minus 0 is just x times x minus 7. At this point, I can leave it like that. The only thing you guys probably have noticed is that we do not know our a value. So in order to solve for the a value, we need another point that we can plug in to substitute for x and y so that we can get a by itself. So unless we have values we can substitute for x and y, we can't solve for a. As a reminder, you can't plug in the x-intercepts because if you plugged in 7, it would cancel out and the a would cancel out to 0, so you wouldn't be able to solve out for a. So if you plug in the x-intercept, since you plugged into factored form, it would actually just cancel out your a value and you would not be able to solve for it. If you don't believe me, try plugging in the points and solving for a, you'll see it's not possible. So we need a third point. Luckily, they give us another point, so it reached a height of 2 feet after 1 second. So we're gonna, step 4, solve for a with a third point. So in this case, I know my third point is going to be 1, 2. So after 1 second, it reaches a height of 2. So I substitute that for y and x. So I have 2 equals a times 1 minus 7. So 2 is equal to 1 minus 7 is negative 6 times 1 is still negative 6. So I have negative 6a. I divide by negative 6 and I get negative 2 over 6, which is the same as negative 1/3 is equal to a. So negative 1/3 is a. So my final thing or final step is to write the equation. So y equals negative 1/3 x, since I'm substituting it for my a value, times x minus 7. And this is an appropriate, acceptable form of my quadratic. I am done with that problem. So this is a perfected form. Let's try another similar looking, or not exactly the same, but actually I'll have you try this one as a quick check. So it's going to be not the same form as a hint, but try it out. A diver dives from a 48-foot springboard and reaches a maximum height of 54 feet after 1 second. Okay, so now I want you to try to write the quadratic that will model this path, or the diver's path. Try that out on your own. Pause it if you need to. I'm going to go over it now. So again, if we're looking at key points, we don't know the x-intercepts because he's not starting on the ground, so that's not helpful, or she's not starting on the ground, so that's not helpful. So then I think of my vertex. So my x-intercepts are unknown. My vertex, however, since it says it's a maximum, if I again do my time is x, my height is y, then I know that after 1 second, max height of 54 feet. So I know my vertex is 154, so I'm going to use my vertex form. So I have y equals a times x minus 1 squared plus 54. Again, we have to solve for a, and to do that, we need another point. So luckily, they gave me that other point with 48 feet, and that's the initial height. So I know that's a 0, 48. So at time 0, it's at 48 feet, since initially the time is 0, 48 feet is the height of the starting board. So I'm going to substitute that in for my y and x. So I have 48 equals a times 0 minus 1 squared plus 54. So 48 equals negative, or 0 minus 1 is negative 1. Negative 1 squared is just 1. So then it's 1a, or just a, plus 54. I subtract 54 from both sides, and I get negative 6 is equal to a. So my final answer for this problem, or final equation for this problem, is y equals negative 6 x minus 1 squared plus 54. So this would be the path that that diver followed. So these are the most common types of problems you'll probably work with, but there's also one more trickier type of problem that we would use standard form to start with. So factored in vertex, hopefully you'll be able to identify if it's the x-intercepts or the maximum or minimum or the vertex of the graph. But we're gonna do one more example that's a bit trickier. I might not have time to finish all of it, but we'll try it out. So a man throws a ball off a building and records the height of the ball at different times. As shown in the table. So our table is going to be our time in seconds and our height in feet. And so we have 0, 1, 2, 3, and 46, 63, 48, and 1. So this is our table here. Just as a reminder, our time is X, our height is Y. So we're again identifying key features. We don't know the x-intercepts because we only have, we don't have any y values that are equal to 0. So none of our y's are 0, so we don't know any of the x-intercepts. We don't know the vertex because it doesn't precisely indicate where it turns. So we know it's somewhere between 0 and 2, but we don't know exactly where, so we don't know our vertex. So since we don't know either of these things, we're going to have to go with our third option of standard form. So again, we went through the first two steps, identify our key features. We don't have any that we know, so we're going to choose the most helpful form. It's going to be standard since it can't be factored or vertex form. So I'm going to use standard form. I have y equals ax squared plus bx plus c. And what I'm going to do is try to make a, since I have so many points, I'm going to try to make a system of equations. So we're going to, well, I'll write in our steps, we identify key features, choose form. And now since we're using standard, I'm going to substitute points or substitute coordinates to make a system of equations. So throwback to unit 3, we're going to substitute coordinates to make a system of equations. So I have 3 variables. I need to solve for a, b, and c to get my standard form. So I'm going to need at least 3 equations, or I need to use at least 3 of these points. So first thing I'm going to do, I'll plug in 46 for y equals a times 0 squared plus b times 0 plus c. The zeros cancel that out, so I get 46 is equal to c. So that's easy. I solve for one of my variables right off the bat, which will make it easier to solve for my other 2. So the next point we have is 63 equals a times 1 squared plus b times 1 plus, now I'll just plug in 46 for my c value since I know that that's what that is. And I get 63 equals 1 squared is just 1 times a is a, b times 1 is b, plus 46. And if I solve that out, so I get a and b alone on one side, I end up with 17 equals a plus b. So now I have one equation in terms of a and b, but to solve my system, I need 2. So I'll use my third point. So 48 equals a times 2 squared plus b times 2 plus 46, which leaves me with 48 equals 4a plus 2b plus 46. And then subtract 46 from both sides, and I get 4a plus 2b. All right. At this point, that's a 2, sorry, 2b. I'm not going to finish solving out this system for the sake of time. If you would like to have me finish going over this in class, I can. I will give you a bonus point if you finish solving the system on your own. So the last step would be solve system for a, b, and c. And then lastly, you'd write the equation of the quadratic. So if you have time, finish that on your own. If not, we'll finish going over it together in class. But make sure you write down any questions you have so we can go over them.